Everybody, my name is Ken Jones, and I'm coming to you from our Salem, New Hampshire headquarters location, the Paris of the Northeast. And I am a technical marketing engineer working for Extreme Networks. Today, we're here to talk about application analytics, application telemetry, and how application telemetry can be used in your network with some tips and tricks about configuring it and things that you need to have enabled. I'll be basically accepting questions, and those can be entered into the panel that's available on the interface that you're with. And those will be asked to me by Steve Doe, who's joining me as a moderator. So every now and then you're going to hear his voice. Any questions that we don't get to during the course of the session will be answered on the hub. So at the end of this session, we will have a link to that, and you can go there to get to any answers that we don't cover during the course of this time. So let me just get to it right now, and we'll move on with this. So tip number one that I want to actually talk about is to keep your endpoint locations updated. Endpoint locations are kind of not really actually a new thing, but they are different. They used to be called the network hierarchy, and it was configured right in the analytics engine itself. So basically, when you brought analytics up, you would configure your layer 3 networks that you were going to be looking at. Several builds ago, we moved that away from the analytics engine, and we put it instead as part of the network within the sites engine. So within your sites, you list out all your layer 3 networks that you're going to actually be viewing, the things that are available on your network. And you list out an alias for those networks. The alias is very important because that's how basically you have the ability to filter through those layer 3 networks to know where the different performance aspects of those networks are. So when you're going through and churning through the flow of data that's coming in, you can use that alias to actually filter everything out. Without the alias, then basically everything sits in a site and it doesn't really make much sense. So for instance, if I were to take that thing out and provide an update and then just go over to the analytics engine itself into the application flows tab, you'll notice that basically all the flows come up and they're divided out by their networks. But within here, anything within that particular network that I erased, it doesn't show me what network it actually is. Instead, it just shows me the site where it is. So you don't really get a full view of what it is that you're looking at and where that network exists. So that's my first tip, is to make sure that that particular alias information is loaded and available, because that will give you the ability to see more of your network and to filter better. The second thing that I wanted to point out is the necessity for a catch-all network. Not everybody does this, but it is very important. Basically, all the RFC 1918 networks, all of your networks that fall within that range should be put into your network hierarchy, into the endpoint locations. Basically, what happens here is that this is how the analytics engine is able to decide what is an internal network and what is an external network. If you don't list it within here, then the analytics engine believes that it's the internet. So this way, we're able to log all of the information for all your internal networks. And then you have the ability to be able to tell what's an internal network and what's an external network. The other reason for a catch-all network is because what you really want to be able to do is define all the networks that you're using and know where those networks are. And this is a real good way of accounting for all your networks. If you have, your main goal here is to make sure that you don't really have any flows that fall in the catch-all networks. Everything should be defined. So, if I were to go into analytics engine and look up from a browser standpoint into all of my sites and just look for the number of clients and just look in that site for the catch-all network, which is right here, I would want to see none. Instead, I see 26 clients that I currently have within the last interval, in the last hour, that are on a network that I haven't yet defined. So these are arguably networks that you don't know about. And these are the things that we want to eliminate. So then the goal would be to go into application flows, look at those particular flows that are in the catch-all networks, find out what those networks are, and then put them into a site someplace. Once we have all that stuff defined, then you have a better view of your network. You have a better understanding of where your flows are coming from and where your applications are coming from across that network. Now, the third necessity for creating a well-defined endpoint location system is this. So basically, when you have your endpoint locations for a particular site, what you'll also want to have the ability to do is to choose an analytics engine that is the home engine for that particular site. And in this case, I only have one analytics engine, but if you have 2 or 3 or 4 analytics engines, what you want to be able to do is pick a home location for those particular flows. So that's where those flows are stored in their cache on that particular home engine. Also, along with that, you get to define a better define what kind of network actually exists within those sites, whether it's an access network, whether it's a data center network, whether it's the core of the network. That's kind of important as well. So one of the things that an analytics engine has to do when it sees the flow information is to figure out who's the client, who initiated a flow, and who's the server who's answering that flow. And that's not always really able to be determined by the raw flow information coming back and forth when it's seen by the telemetry engines that are distributed across the network. So if you have a network or a site that's consisted mostly of access networks, like the access edge of the network, and you name it as an access network and give it the home engine, then the analytics engine has a better idea, a better reason of defining that particular aspect of it, and it does a better job of giving you the information that you actually need. So that is, in short, tip number 1. Tip number 2, there are 2 types of data that come in from application telemetry and that are stored within the application analytics. One is aggregated data and the other is live data. Aggregated data really is meant for long-term statistics. It's meant for trending information. It's meant for knowing what, doing comparison about things that are happening now as opposed to things that were happening 6 months ago. So when you're planning things for your network, or when you're planning upgrades, when you're looking at how information is consumed across your network, you can long-term trend that information using this data. Everything that's in top end dashboards and reports, and most of the stuff in browser views, that's all aggregated data. That doesn't really help you out with live troubleshooting of what's going on in the network. The live data that can be used for stuff that you want to look at right now, like the application flows that we showed, response time dashboards, network service and track application dashboards, those things contain more live data and can be used for the here and now for what's actually going on. Let me show you. So the dashboards over here, analytics dashboard, sorry. See, these dashboards are all basically, for the most part, these are aggregated data. If I look at my top application groups over here, this is basically showing me the network and application response times for these particular business applications, these application groups across the time. But it's not what's happening directly now. It's what happened on average over the course of the last 6 hours. If somebody's having an issue with a specific application right now, this view is not going to really do much for you as far as telling what's going on, right at this particular second. However, going to the response time dashboard, this is actually showing you information that's being updated every 30 seconds on whatever application, whatever protocol it is that you're interested in. So you can filter on whatever you need, and it'll show you what's going on right now. And that information gets updated every, I think, 15 or 30 seconds and can be utilized along the way. So if somebody calls in and they're having an issue, you can look at this particular dashboard and tell if there's an issue network-wide, or you can go into the application flows tab and you can look up that particular users tab or the application that they're looking at, and you can see that in real time. To give you an example, one of the things that we do here at Extreme Networks is we run a network for a large healthcare conference that happens every year here in the US. And it's called the HIMSS conference. And basically about 45,000 people show up for this conference. And we run basically the wireless network for a lot of the vendors. And they utilize our networking in order to get out. And I configured all this stuff and utilized application analytics and telemetry in order to be able to look at that network traffic. One of the vendors that was there was this vendor with a bunch of tablets and a wayfinding app. And the wayfinding app, basically, they give it to every user who came into this area. And they could say, okay, I want to go see this vendor. And they click on that vendor, and it would give them a map of how to get from where they were to where that vendor actually was. The people who were running that came up to me and said, this network is not working well. None of these applications are working. It's very, very slow. All the network is terrible. Things are bad. I was very, quickly and easily, because I had them nicely defined within my network map, I just pulled up the network that was associated with them, brought up basically all of their tablets. There's about 200 of them or so. And I could tell right away that basically the network response time of all the flows that they were seeing was really good, somewhere in between like 40 and 50 milliseconds. But some of the application response times were up to 1, 2, 3 seconds long, and 3 seconds is basically forever. So what was happening, we found out, was that the application that they were going to was basically all going to a single server that was the server for this particular company. So all of these tablets, every 30 seconds, were trying to go out to the internet and get an update from this server. And the server wasn't able to service that, and they were failing. And that was causing everything that they were doing to work more slowly. So what we were able to do was go into the application, have it not go get the updates, and then it fixed the entire problem. And we were able to troubleshoot this, see this problem, and fix it inside of like 15, 20 minutes because of this real-time view. So that's what the importance is of knowing the real-time traffic and being able to look at it, as opposed to the aggregated traffic that happens over time. I'm gonna take a little drink right now. Steve, are there any questions that have come in thus far?
Yes, Ken, I think we're going to pull out this as your first question. This is a good one. The question goes, my application flows tab only retains my flows for a day or so. Is there anything I can do about that?
Yeah, basically you can. So the thing about the application flows tab is that this is a cache. It's just basically a static cache of data. It's only so big. So the length of time that your flows are kept within this particular view are directly related to how busy your network is. If you have a really busy network, the flows, the older flows will drop off at the end. If you have a not so busy network, then you have those flows for a greater deal of time. But having said that, this goes back to basically the first point that I made. If you have a site configured and you have the endpoint locations all set, you can basically have more than one home engine. So if you have one application analytics engine, by all means, just go ahead and deploy a second application engine. Put some of the sites pointing at one and some of the sites pointing at another. And now you've basically doubled your cache. Remember, when we license all this stuff, we license for the users on the network, how many clients we're actually seeing. We don't sell the application analytics engines when they're in VMware. They're free. It doesn't matter to us whether you deploy one or whether you deploy 4. It's all how you need to divide up your network. So you can definitely increase the amount of time that those flows are stored by just increasing the storage facility by deploying more application analytics engines. So with that, we get back to the PowerPoint over here. And tip number 3. Tip number 3, the network service dashboard is your friend. I don't know if anybody who has application analytics deployed on the network, if they're using application telemetry, if they've actually viewed the network services dashboard, but that is right over here. The network service dashboard really kind of looks at some key protocols, some key services, not really application level stuff, but services that are necessary for anybody's network to work. Because when somebody calls into the help desk and says, the internet is broken or everything's really slow or something like that, I mean, the first thing that you want to check really is whether their DNS is working. So it's good to go to this network services dashboard and, for instance, look at your DNS on whole. What this dashboard shows is basically what I have for average, a running average on this point over the course of the last 24 hours for my DNS traffic for my different sites. And over here would be the high end of the average, and this would be the average of what we're doing. Whenever this traffic goes over what is an expected value, when it gets like one deviation over what is normally expected, then this this graph will turn red and indicate that basically, okay, we have, some problem here with this particular thing, whether it's DNS, whether it's, radius, whether it's LDAP or whatever, right? So that way you'll know right off the bat whether we're having like a big problem or not. So that's really kind of like a good thing to come through. And this also is like a real-time dashboard. So it updates like every 30 seconds, every minute, something like that. So do we have any other questions that are associated with that particular thing, Steve?
Yeah, it looks like I can pull this one out. This one's going to be kind of in alignment with that topic. Let's see, can I use application telemetry information to trigger alarms? For instance, when a specific application starts performing poorly?
Yeah, you can. I mean, it's kind of a good thing to actually do, because even when this particular dashboard, if it shows you that it's gone over one standard deviation, that's only for that particular snapshot, and it might not be a problem. It might just be, in this particular instance at this time that there was like a glitch in the network. But more long-term things, we do have an alarms and events capability within here, and there are threshold alarms that you can create. So, I have a default one that's in here for application analytics that's looking at my real-time usage. And whenever I see an application like DNS is all configurable, and the application response time goes above 2 seconds, then I want to be alerted. And these are very easy to create right from within here. And then you can create an action off of that. So action being, in this case, just send me an email. So basically, whenever I see that happen, send me an email. Other actions that can be taken within here are to, run specific tasks, to do workflows, and not for nothing, but the tasks, actions, and the workflows that are going to be covered in a later session. But there are a lot of things that you can do within this alarms and events interface that can basically automate a lot of your reactions to things that happen on the network. Another thing, when you have something like an email response, is to always set the alarm suppression. What you don't want to be is your own source of spam. So basically, I set this thing so that it will by maximum send me only 5 emails during the course of any given hour, and then reset. So that way I don't end up getting 1,000 different emails telling me that this, that, or the other application is performing poorly. So that's always a good thing to know as well, basically, that you can do those particular things. Now, that's tip number 3, the service dashboard. Tip number 4 is basically tracked applications. Now, just like the network services, there's another dashboard within here that is instead based on specific applications. This is completely configurable. So you can take any kind of application that's important to you, and you can have a tracked applications dashboard for that. So instead of just tracking the services, this tracks the network and application response times for specific applications. So for instance, this one is, in this particular instance, is it sounds like it's a horrible thing, but in reality, okay, on this particular network, the Microsoft Corp application is worse than expected by 25 milliseconds. So this isn't necessarily a horrible thing unless it gets a lot worse, but it's alerting you to that particular application. And all this stuff is configured within analytics from the configuration interface. So within configuration over here, tracked applications are basically configured right here. So you just type in the application that you want based on whatever it is that you're actually looking for. So, if I wanted to type in something about Amazon, then, Amazon Web Services, and I could just add that application. And then it would end up being tracked within that interface, right? So these are very important. So any kind of tracked application, any kind of application that's important to you. I know a lot in the education industry where, we're tracking things about outbound testing sites and things on the internet like that, that they would take those applications and put those in here and track those things very closely during the course of any kind of like testings and stuff like that. So these are a really good thing to actually keep track of. And I have one more lovely tip that's very important, which is fingerprints. Fingerprints don't have to be complicated. We talk a lot to customers, and then they want to be able to create their own fingerprints, which we totally are for, because you should be able to create your own fingerprints that track the things that you actually need to track. But they don't have to be really complicated fingerprints in order to be effective. Let me show you. So there's a fingerprint interface, for instance. And just type in what we have here for VMware. So I searched in here, and we have a bunch of different VMware fingerprints. So let me just show you the definition of this one. Now this one is isn't overly complicated, but still, basically we're looking for anything that's in destination port 902, but also we're basically looking at a match offset of 4, and we're looking for this specific pattern. And when we find that destination port in this specific pattern, that means that we've located basically a connection to EXXI to vCenter server for VMware. Now, obviously somebody had to find that information out. They had to, basically get a Wireshark trace, figure out how it actually worked, and make that pattern and make that signature. And that's completely available to be able to do. But here's a different one that we created customly. Now this one is much easier, and it's just done with a simple right click. Hey, if I see this particular address on port 443, then I know that vCenter is having a conversation with the VMware host. Signatures or fingerprints like this can be configured on anybody's network. I mean, everybody has, hey, I have this server, and this server does this particular activity all the time. This is my database backup server, and it does, it works on these particular ports, and it does this kind of backup, and I want to track it. So you can easily and quickly create fingerprints with a mere right click from the application flows tab that is tied to just nothing more than IP address and a port. And it seems simple, but it's actually a very, very effective way of being able to track a lot of things that you do every day on your network. So I wholly support everybody going through and looking at their flows tab and looking at the things that they have in there, and being able to say, oh yeah, I know exactly what this IP address is, and I know what it's doing, and I want to be able to track that, and just right click and make a fingerprint for it. That can be done, if you haven't done it, from in the application flows tab. From just basically right clicking on any singular flow. So, from within here, add fingerprints, and it gives you basically the ability to just go, from the port and the IP address, or just the port itself, or whatever it is that you need to actually do. It doesn't have to be a complicated thing. It'd be relatively straightforward and relatively easy. So with that, I mean, those are basically my 5 quick tips. I don't know, Steve, if there are any other questions that are in there. I know we're probably not running really long on time or anything like that, but if you have anything else, please let me have it.
I think we got 3 or 4 minutes left, so we'll change lanes with this question. Can the information gathered by application telemetry be forwarded to other systems like a SIM or a log aggregator?
Absolutely. So this is something that's really kind of like built into everything that we actually do. So when you configure all this stuff, you'll notice that within the telemetry engine itself, there's an Ipfix dashflow exporter, which is right over here. If I enable that, I can choose where I want to send it. I can choose the port that I want to send, and I can choose what type of traffic that I actually want to send to it. And not for nothing, but we've built some integrations into all this stuff, which I can bring up pretty quickly from within here. So we've built in applications for integrations for not only Splunk, but for Elastic as well. Those are a couple of well-known, aggregation packets. And there's a file on the analytics engine itself that has not only the files that you need in order to integrate it, in order to execute everything, but it's just a complete modification file so that you know exactly what you're doing and exactly how to integrate that information in. Because I mean, all of these SIMs and all of these log aggregation devices, the first thing that they have to do when they see the data, they have to normalize it and basically integrate it in so that they can make sense of the information that you're sending. We've basically done that work for you for Splunk and Elasticstack. So if you follow our directions and forward that information in, it'll automatically go into those two integrations and work right off the bat without having to do any kind of heavy lifting. Anything else, Steve?
Yep, I think we have just a couple of minutes, so I'm not sure you're going to get through this one, but we're going to give it a shot anyways. So here's the question. I've been told that application telemetry is based on SFlow. If the data is sampled like SFlow is, aren't you missing a lot of the application information?
Oh, okay. I'm going to leave this last slide up at the same time I'm answering this question because I know I'm going to run out of time. So yes, at its core, it's kind of based on SFlow, but it's kind of a misnomer. At the beginning, they called this technology SFlow Plus because it was kind of based on some kind of NetFlow traffic. But SFlow doesn't really do a lot as far as this integration is concerned. In reality, SFlow is basically a long-term searching mechanism of monitoring basically ports. So we'll be able to look at all the information going across the switch, and over the course of X amount of time, if 60% of your traffic of what you brought in from a sample data was web traffic, then we can just assume that 60% of all your traffic was web traffic. And this really plays out to be true. We use that information just to basically show how large and how much traffic there was of specific things. But how we define the traffic is really done through a succession of ACLs that are pushed down to each individual switch in the network. So there are about 130, I think, or so, small ACLs that are looking at everything, like all your DNS traffic, all your HTTP traffic, all your SYNs, all your FINs, all your X, a lot of your radius traffic, basically a lot of little
just a few
tidbits
seconds,
of traffic.
Ken.
And that's how it works.
Left.
Okay, so in any case, we'll have a better answer for that and more on the hub at community.extremenetworks.com. Thank you very much for your time. Have a lovely day.